When you hear the term systems engineering, your mind probably jumps to endless spreadsheets of requirements, rigid traceability matrices, and highly dense architecture models. But if a team limits this discipline strictly to managing technical documentation, a critical blind spot opens up. A product can hit every single technical specification perfectly on paper and still fail entirely the moment it reaches the customer. This failure happens because a system includes the complete delivered product, operating within an unpredictable physical environment and answering to the needs of real people. Requirements and architecture are critical, but they represent exactly 50% of a system's true value. The blank space leaves projects vulnerable to unseen execution risks. To complete the picture, we fill the missing half: strategic trade-offs, cost optimization, risk management, and cross-team alignment. Nailing the technical design keeps you in the game, but mastering this invisible, business-focused half is what actually determines if a product succeeds commercially. To manage those business realities effectively, we actually have to rewind the project timeline. This work begins long before any CAD models or software code are written. The true origin point of effective systems engineering is the bidding stage, specifically when a request for quote or RFQ arrives from a customer asking for a proposed price and solution. Ignoring systems thinking at this early stage creates immediate hazards. A team might misprice the bid entirely, severely underestimate the engineering resources required, or propose a solution that is technically impossible to build within budget. Applying systems thinking right at the RFQ forces the commercial and technical teams into alignment early. It guarantees that the concept pitched to the customer matches physical reality and financial constraints. By bridging that gap, systems engineering protects a company's profit margins before a single technical drawing is ever created. Once the bid is won and the core engineering phase begins, a new friction point emerges. This is where strict technical requirements inevitably collide with harsh business realities. To keep the project viable, engineers must master the art of the trade-off. This radar chart maps those competing project variables, showing the delicate balance between cost optimization, risk coverage, regulatory compliance, and hard engineering constraints. Watch how these variables react to one another. If a customer desire spikes outward, the system has to compensate. The cost and constraint axes automatically adjust inward to maintain equilibrium against rigid physical and financial limits. And those customer requirements rarely sit still. They evolve continuously throughout development, requiring constant gap analysis to ensure the new demands don't break the existing design. In this phase, systems engineering operates as a dynamic resolution mechanism, absorbing the pressure of competing demands so the final product doesn't collapse under its own weight. Managing those competing demands requires moving beyond technical variables and focusing on the human element. This level of responsibility cannot sit within a single technical domain. You cannot rely on the mechanical, electrical, or software engineering teams to handle this in isolation. Navigating these complexities demands a highly refined set of soft skills. It takes elite communication, high-stakes negotiation, and the ability to drive clear, cross-functional decision-making. Look at this network node map. Typically, departments like engineering, manufacturing, quality, and the customer operate in isolated clusters. Systems engineering acts as the glowing central hub, suddenly linking them together and forcing vital data to flow between them. Without that centralized human integration actively breaking down departmental silos, achieving total product alignment is impossible. Zooming out to view the entire product timeline, the true scope of the discipline becomes clear. It is a continuous practice, not a finite phase you can check off a list. This timeline stretches from the initial RFQ all the way to SOP, or start of production, the point where the final product rolls off the manufacturing line. Notice the continuous sine wave weaving through every milestone: design, build, and test. That is the constant oversight of systems engineering. Returning to our starting point, defining an architecture or cataloging technical requirements only sets the stage for the real work. It is the holistic, cross-functional discipline entirely dedicated to ensuring that the product and the business behind it actually succeeds in the real world.